Hi everyone, my name is Sanjeev. In this video, I will demo how to use Anypoint MQ in Mule application. We can use Anypoint MQ to implement a scalable and reliable solution. Anypoint MQ is used in case of asynchronous message scenarios. It is fully hosted cloud service and it is fully integrated in Anypoint platform. Anypoint MQ provide management console where you can create queue, you can create message exchange, you can create FIFO queue, you can configure DLQ, dead letter queue, you can configure the security by using encrypted queues. When Mule application want to communicate in a scalable and reliable way, we can use the queue. Publisher send the message to the queue and subscriber receive the message from the queue. There could be many publisher that could send the message to the queue, but that message would be received by only one subscriber. To implement the PubSub design pattern, we can use message exchange, where message can be delivered to the multiple consumer. That means the message sent by the publisher will be received by all the subscribers. If the ordering of the message is important, then we can use FIFO queue. We can use dead letter queue to send the undelivered message to the DLQ. So we can configure the DLQ in queue configuration, and message can be delivered to the DLQ after certain number of unsuccessful delivery attempts. We can provide the security by using encrypted queue, so message can be encrypted. Anypoint MQ have Anypoint MQ connector and REST API. So Mule application can use MQ connector to publish and subscribe and consume the message. And non-Mule application can use REST API to publish, subscribe, and consume the messages. Anypoint MQ management console also provide the option to purge the queue, so you can delete all the messages inside the queue. It also shows how many messages are in queue and how many messages are in flight message status. You can analyze the usage statistics on the number of messages. In this demo, I will show how to publish the message to the queue, how to subscribe the message from the queue, how to consume the message from the queue, and I will also talk about the acknowledgement modes, different acknowledgement mode for the subscriber. I will also demo PubSub scenario where the same message sent by publishers will be delivered to all the consumers. I will demo the dead letter queue, and at the end I will show you how to implement circuit breaker pattern in Anypoint MQ. Let's start demo now. I have created Mule application MQ demo. Let me show you the Anypoint MQ management console configurations first that I would be using in these demo applications. So I have copied the management console screenshots in this PPT. Anypoint MQ is fully integrated with the Anypoint platform. It is cloud hosted service. If we click the MQ option right here, we will go to the Anypoint management console. I have created these destinations in Anypoint MQ management console. There are 6 destinations. I'm using 4 queues. These are the names. One FIFO queue. So this is a FIFO queue. And I'm using one exchange. This is exchange. I will be using these destinations to demo the Anypoint MQ inside the Mule application. Here is a sample configuration. I copied the product queue configuration. Everything is default configuration here. To communicate to the queue or exchange, we need a client ID, client app ID, client app secret, and URL. If we click the copy here in the management console, then we can click the connector version 4 and later we can get the URL. We need that URL for configuration. I have created a client app. I have copied the client app ID and client app secret. That also I need to configure in Mule application. Anypoint management console also provide the different options to purge the messages from the queue. You can purge all messages from the queue. You can delete the queue. It also shows the how many messages are in queue state and how many messages are in flight state. When a message is published to the queue, it comes in queue state. When the message is received by subscriber, the message comes in flight state. Then depending on the processing status and acknowledgement mode, the message can go back to the queue or it can be deleted from the queue. If message successfully processed, then message will be deleted from the queue. Depending on the acknowledgement mode, the message can be sent back to the queue and this video available to be subscribed by another subscriber. You can also view the statics of all the messages here. Now I will go to the Anypoint Studio. So here I have added the Anypoint MQ connector. You can go to the Exchange and you can type the Anypoint MQ and then you can add the Anypoint MQ connector here. It has a publish operation, it has subscriber operation, it has consume and then acknowledgement, NACK, no acknowledgement operation. In this flow, I'm using HTTP listener. This is the endpoint. I'm going to send a message from Postman and that message will come here. I'm logging the payload, logging the message, and then I'm publishing that message to the disk queue. I have created a property file for queue names. So this is a queue name. I have created a secured configuration file for MQ URL, client app ID and client app secret. So here to publish the message, we need to configure the destination. This is the queue name. And then we need to provide a connector configuration. In this connector configuration, I'm using secure property file. I'm providing the URL, MQ URL, client app ID and client secret. These value we can get from the Anypoint MQ management console. I showed you here in this configuration right here. So we can get the client app ID, client secret and URL I described when I was describing this slide. So I'm invoking the publish method, then I'm logging the message, published message, and I'm sending this payload message published to the postman back. I have created another flow. So in this flow, I used a subscriber operation. The subscriber will subscribe the message. Here we need to provide the queue name. So we need to configure queue name and I'm using the same configuration to connect to the queue. When the subscriber receives the message, I'm logging the new message received message and in second logger I'm logging the payload actual message. So let me run the application. So Mule application is running, it is deployed. Let me clear the console. Now I will go to the postman and I will send a message to this endpoint, publish endpoint. Message will come here. It will log the payload and then I'm going to publish the message to this queue and I'm going to print message published and in postman we will receive the message has been published. Message published, message will receive that. Once the message is published in the queue, this message will be sent to the subscriber by Anypoint MQ. So this subscriber will receive the message from the product queue. Once this message comes to the subscriber, it will be processed, and here we are logging the message, new message received, and then I'm logging the payload, the message that is received by this subscriber. So let me go to the Postman, and here I'm sending the message here. Click send button. We got the response, message published. You can see that I'm logging the message, then message being published, and here we are saying message published. Then the subscriber will subscribe the message will come to the subscriber source, and then we are printing new message received. So we got the new message received, and here we are printing the actual message. So this is actual message. These both flow are totally independent. They not depend on each other. And Anypoint MQ is providing the asynchronous nature of message communication. The publisher can publish the message at any time, and the message sits inside the queue. And this thread, the publish thread ends. Then the message comes to the subscriber flow. If subscriber is not ready, then message sits inside the queue. When subscriber comes back, it receives the message, and then it is processed by the rest of the flow. So both flow are independent, and we are processing the message, communicating the message totally asynchronous manner. The first thread does not wait for the processing of the message to be completed. The publisher only publish the message, and the subscriber receive the message, and it can do whatever processing business logic need to be implemented on the message. Now I will show you the consume method. So I have created a separate flow. Let me stop this flow. So when message will be published to the queue, it will not come automatically to the consumer. We will invoke the consume operation by calling http listener / consume endpoint. In this source, either we can trigger by http listener / consume endpoint, or we can write a scheduler here. But in this case, in my demo, I have used the http listener. So I will invoke this listener / consume endpoint, and then I will invoke the consume operation. So in this, I am providing the queue name. So we have to configure the queue name, and the configuration is same. I'm providing the MQ URL, client app ID, and client secret. So let me stop the application, and I will start the application. Mule application has been started. It is running. Let me clear the console. Now I'm going to publish the message. So I will go to the Postman. Here I'm going to publish the message. Send. Message published. And we can see that here. Message has been published. Right now it is not consumed because we stopped this flow. So there is no subscriber. We will consume using consume operation. So I will call this / consume endpoint. So click send. We got the message. Here I'm just consuming the message and then transferring that message in a JSON format to the postman, caller of the API. Let me invoke the consume operation again without publishing a message. So right now I'm not publishing any message here. This message already has been consumed. I can clear the console here. I will go to the postman and I will consume the message again. Right now there is no message in the queue. So we got the error. Get consume message did polling for 10 second, 10,000 millisecond, and it did not receive any message. So it threw Anypoint MQ timeout error. So if there is no message, this consume method will throw Anypoint MQ timeout error. We don't want that error. We can set the polling timeout to 0. In that case, we won't see this error. The consume operation will wait for 10 seconds, and if it does not receive any message, it will return the null payload. So you can read more about this about consume operation and the subscribe operation on docs.mule.com. You can get all that more understanding, more detail here regarding subscriber also. Now let me show you the acknowledgement mode. So subscriber have 3 different acknowledgement modes. Let me go to the PPT. Subscriber have auto acknowledgement mode, immediate acknowledgement mode, and manual acknowledgement mode. This is default acknowledgement mode. Flow process the message and send acknowledgement if flow does not have any error. If gets error, it will send the no acknowledgement neck. That means in case of auto acknowledgement, if we receive an error, suppose we are calling an external service or we are calling database, we are trying to connect to database. If we are getting an error, in that case, neck will be returned. If this processing is successful, there is no error in the flow, then the acknowledgement will be sent. So auto is a default acknowledgement mode. Then comes immediate. In case of immediate acknowledgement mode, subscriber receive the message and it send the acknowledgement right away. That means when the message comes here, before it delivered here this side, processing side for processing, first it will acknowledge the message. If there are any problem in receiving the message by subscriber, then only it will send the red neck. If it can receive the successfully without processing, it will send the acknowledgement right away. That is the meaning of immediate. In case of manual, we have more control. So we can send the acknowledgement or neck, no acknowledgement based on the condition, business logic. So in this case, we have full control. So in case of manual, depending on the situation, you can send add or you can send neck. Now I will demonstrate how the acknowledgement mode works. Let me change the initial state to the default, that means started. Here I'm demoing the acknowledgement and no acknowledgement based on the some business logic. It is a dummy logic. In real situation, usually we invoke the service or try to connect to database, and then we are not able to connect to that service, or service is not available or times out, or we are not able to connect to database. On those cases, we send the no acknowledgement. But just to complete the demo, I'm just using this payload.price attribute, and I'm saying if it is more than 5,000, I need to send acknowledgement. Otherwise, it will send NAC, no acknowledgement. This acknowledgement and no acknowledgement need a acknowledgement token. So once the message comes in the flow, I'm saving this acknowledgement token. So I'm getting from attributes dot acknowledgement token. I'm saving inside a variable, and then I'm using here when I'm sending the acknowledgement and no acknowledgement. So let me stop this application and I will run the application. Application has been started. Let me clear the console. Now I am published the message. I'm going to publish the message using /publish operation again. Message will come here, and based on the price value, it will acknowledge or no acknowledge. So let me send first 7,000 price value, send, message published. We can see that message came here, and then we publish the message. Then subscriber got the message and it printed this logger message because price value is greater than 5,000. So it came here by choice router, and that's why we are saying message will be deleted from the queue. In this case, we acknowledge the message processed successfully. So message will be deleted from the queue. So message will be deleted from the product queue. It will not be in the in queue state. Now let me send one more message. I will this time send the price value 2000. Send it. So in this case, we receive the message published first. We receive the message, and here message will be returned to the queue. So we are coming in this choice router, coming to the default, and here we are printing message will be returned to the queue, and then we are sending no acknowledgement. Because we are sending no acknowledgement, message being considered not successfully processed, and we are telling to the queue that this message has not processed, it need to be returned to the queue, and message is getting returned to the queue. That's why we are getting the message back, because same subscriber get the message again. That's why this is going in this flow again, and we are getting the same message in the console. We don't have another subscriber. If we would have been another subscriber, that would have been taken this message and processed the business logic for the all the product whose price value is less than 5,000. We could have done different processing, but right now in our demo we don't have that subscriber. So message is coming back to the same subscriber, and we are not able to handle this situation, and that's why it's keep printing same. In real scenario, there could be different subscriber to process the different type of messages. Here the message could be processed for the price value more than 5,000. There could be different subscriber. When this message is written by NAC, because price value is less, it is returned back to the queue. Different subscriber could have taken that message and could have processed differently. But in this case, is getting delivered again and again. We can handle this situation, a number of delivery attempt, unsuccessful delivery attempt by configuring the DLQ. So I will show you the DLQ in my demo. But before that, let me show you the configuration. I have a inventory queue and I have inventory DLQ. They are queues, and I'm going to configure inventory DLQ as a DLQ dead letter queue in the inventory queue configuration. So let me show you the configuration. Here is the DLQ configuration for inventory queue. You turn on this option, assign dead letter queue. You will get the list of the queues. So from the list of the queues, I selected the inventory DLQ, and inventory DLQ is the dead letter queue for the inventory queue. And here delivery attempts before reroute are 4. That means it will delivered, the message will be delivered to the inventory queue 4 times, and if it is not processed successfully, the message will be delivered to the dead letter queue, inventory DLQ. So let me go back to the Anypoint console. And here is the application to demonstrate the dead letter queue. Here I have created a flow where endpoint is inventory, and I am publishing the message to the inventory queue. I'm using the same configuration to connect to the queue. Here I'm saying message published if it's successfully published, and here I'm subscribing the inventory message. Once message comes, I'm logging inventory message received, and then I'm printing the actual message. So let me run this application. Mule application has been deployed, it's running. Let me clear the console. Now I will go to the inventory endpoint and publish an inventory message. So I'm sending message. So message has been published, and then it came to subscriber because subscriber is listening to the message. So message published, new inventory message received, we are getting from here, and then we are printing the message. Now let me stop this flow. And I will start this flow. In this flow, I'm subscribing to the inventory message, inventory queue. Here I'm logging new inventory message received. And here I'm raising the error, inventory colon invalid message, invalid delivery. So because we have acknowledgement mode auto, here I'm raising the error. Because of this error, message will not be acknowledged, no acknowledgement will be sent, and the message will be returned back to the queue. So let me run this application. Mule application has been deployed. Let me clear the console. Now this flow is stopped. This flow is running. That means this subscriber will get the message, and here error will be raised. That means the message will be returned to the inventory queue, it will return 4 times because we have configured the DLQ and delivery attempt before readout is 4. It will deliver to this queue 4 times. So because of this dead letter queue configuration, after 4 failed attempt, we'll send to the inventory DLQ. I will publish a new message to the inventory queue. Click send. Message published. So you can see that this message came. It is published. Then we received the new message, inventory message, that is printed by this logger. We are printing actual message by this logger. Then error is occurring. Invalid inventory. And this message, because of this failure, going back to the queue. Then again, we are getting the message. So this subscriber receiving the message again, printing again, new inventory message received, printing the message, again we are getting the error. So this is happening 4 times. And then after 4 times, the message has been routed to the inventory DLQ because of this configuration. It is sent to the inventory DLQ, and here we have another flow here, and it is subscribing to the inventory DLQ. I can show you the property file, inventory DLQ. Because we are subscribing to the inventory DLQ in this flow, and this flow is in a started state, message coming here, and here we are printing new inventory DLQ message received, and we are printing the actual payload. So after 4 failures, the message has been sent to the DLQ, and DLQ subscriber is getting this message. So this is how DLQ configuration works. Now I will show you the demo for the PubSub publish subscriber design patterns. So we use Exchange in Anypoint MQ. So let me show you the configuration for Exchange, Anypoint Exchange. You have seen that we have created a product order exchange, and this is a configuration, product order exchange. In product order exchange, we can bind the queues. So from the list of the queue, we can configure which all queue that message will be sent. So here I bind inventory queue and shipment queue. So when message will be delivered to the product order exchange, it will be sent to the inventory queue and shipment queue. And the subscriber of the inventory queue and shipment queue will get the same message. So this is how message sent by one publisher will be sent to the multiple subscriber. You need to bind the queues to the exchange, and subscriber of those queues will get the message, and all subscriber will get the same message. So here I'm sending the message to the product order exchange, and I'm subscribing here inventory queue, and in this case I'm subscribing shipment queue. So when I will send publish message to the exchange, this both subscriber will get the message. So using this endpoint /order, I will publish a message to this exchange, and the message will be sent to both queues, and these both subscribers will get the same message. So let me run this Mule application. The application has been started. Let me clear the console. Now I will invoke the /order endpoint and I will send a order from Postman. Click send. So we got the order. Message published to the product order exchange. New order message received by inventory. New order message received by shipment. So both these subscriber receive the same message, and here we are printing the same message by both flows. The message sent to the exchange came to both subscribers. So this is how you can implement the publish subscriber design patterns using Anypoint MQ exchange. Now I will demo the circuit breaker pattern. Here I am going to publish the message to the product queue, and we have subscriber to the product queue. Message received from the queue, message will be processed and new product order will be created. I am logging this message. Then I am calling a service using a flow reference. So here is a service I am invoking, REST service. This I have created a sample service and deployed in Cloud Hub. So let me show you the service. Simply returns the message that product has been created successfully, and I have deployed this service on Cloud Hub. So let me go to the Anypoint platform. I will log in. Here is a service that I deployed. I am invoking this service inside the flow. I am invoking the service. Before I demo the circuit breaker pattern, let me explain what the circuit breaker pattern is. Let's consider the scenario when we publish the message comes to subscriber, we invoke the service right here. If service is up and running, subscriber will get the message will be processed by rest of the flow, everything will be fine. But suppose service is down, we will keep getting the error. We are not able to connect with service, we are getting timeout error. The message will be returned back to the queue because of the message will not be acknowledged because we are getting the error. To handle this scenario, we can configure the circuit breaker. So we can go to subscriber, we can go to the advanced. Here we can configure the circuit breaker by edit inline or by global reference. So I'm using edit inline here. Here we can tell that if we are getting error so many number of time, we will stop receiving the message. Instead of calling the service that is not working, it is not available, we can stop processing the message, and we can do that by configuring the circuit breaker pattern. Let me go to the slide to explain more better in a pictorial manner. When we are able to invoke that service and we are able to process the message successfully and there is no error, that time circuit will be closed. Now we can configure that error threshold. In our example, we configured 3. So when error count goes, when we start getting error like timeout error, HTTP timeout error or connection error, and if that count goes more than threshold, more or equal to the threshold, the circuit will open and it will not receive any new messages from the queue and it will wait for trip timeout. So like here we configured here trip timeout 30. So it will wait for 30 seconds. It will not fetch any message from the queue for 30 seconds. When 30 seconds are over, trip timeout evicted, the circuit will open half and it will try to fetch only just single message. So after 30 seconds, in our case, we will fetch one more message and try to process that message. So we will invoke this service. If there is no error, if we are able to call that service, we are able to successfully process the message, circuit will closed and we start processing the message in normal way. We start getting the message, we call the service again, everything will be normal. But if we get the error, we are still not able to call that service, circuit will open again and it will wait for 30 seconds again. Again, we will fetch one more message. If service is up by that time, circuit will close and we start calling that service and we start fetching the messages and everything will be normal. But if we are again not able to process the message, failure exists, then we will open the circuit again. So in our case, I have not specified any error type. So for any error type, it will count the threshold error count. When it reaches 3 or more, it will wait for 30 seconds and it will not retrieve any new message. Right now our service is up and running. You can see that it is running. So let me run this Mule application. Okay, application is running. Let me clear the console. Let me publish a message to this queue, product queue. I'm publishing a message to the product queue. Message published. So message received. So here we are saying new product message received. New product printer 1 message received. Then it's published. Then I'm printing message published to the queue. So I'm getting message published to the queue. And then from subscriber flow, I'm printing message received from queue. Message will be processed and new product will be created. Message received from queue, message will be processed and new product printer 1 will be created. And then I'm invoking this service. Create endpoint. And here I'm printing the response. So product created successfully. This I'm getting from the service. So I can send more messages. So I have created another product, printer 2. So everything is fine. Now I will shut down this service. I will stop this service. Service has been stopped. I will stop this flow because I want to send few messages to the queue, product queue. I started the application. So application is running. Let me clear the console, and from the postman I will send few product messages. Message published, message published, message published, message published, message published. So I publish these messages 1, 2, 3, printer 4, printer 5. I published it. Here this flow is stopped, so they are already exist in the queue. They are not being subscribed. Now let me change the initial state to default. That is started. So let me show you the configuration. We have here threshold 3, trip timeout 30, and on error type I have not given any error type. That means it will fail on any error. But if you want to specify a particular error, you can put the errors here by separating using comma. We can add the multiple error types here. So, and here I change the subscriber type to polling and fetch size to 2 to make sure that actually I'm able to describe the circuit breaker pattern properly. Because sometime what happens, this condition does not work in my local for error count is equal to threshold. Sometime it reached error count greater than error threshold, means it fails more than 3 times before circuit gets open. So let me run the application. So application is started. It is fetching the records. So and we got the errors here, ST timeout, and right now circuit is open. So it is waiting for 30 seconds. It will remain open for 30 seconds. So we got this message after 30 seconds. Message received. Message will be processed. New product printer 2 will be created. But it failed again. So when we received this message, it was in half open state. Circuit was half open, but it failed again. That means it went back to the open state and it waiting for 30 seconds again. So after 30 seconds, we'll get one more message. Okay, we got one more message, printer 3. So after 30 seconds, it went to the half open position, half open state, and we get the message because it is still failing. So right now it is in open state. So it's going from here to here. From open states, it waiting for 30 seconds, it coming to the half open state. Because message is failing, service is down, it is again going back to the open state. And that's what is happening. It is going this state to this state and this state to this state. And when it is in this state, try to fetch only just one message. And that is the reason we are only getting this message for one product. It's only fetching the one product. So waiting 30 seconds again, and it will try to fetch one record. So out of 5, it will fetch any of the product message. We got the printed 3 again, same message came back. Let's try few more seconds. So we are waiting for trip timeout. Right now in open state. Went to half open. This time it pulled another message, that is a product 4. And as soon as it noticed that message failed again, it went back to the open state again. Now I will start the service again. So I'm starting service. While this service is starting, it will keep pulling the one message because it will go to the half state, half open state, and again wait for 30 seconds in open state until the service start successfully. So service is still starting. Now we got again when it went for a half open state, it pulled the message for printer 2 this time. Previously it was pulling the message for printer 4. This time it pulled the message for printer 2. Again it went to open state because we are getting error. Service is not up yet. Now this time we got printer 3. We got the error again because it takes some time to service to be started again. So still it is switching the circuit state from the half open to the open state. Service still not started. Still we are fetching single message printer 3 this time. Now service has started. Now it will fetch the one message again. It fetched the 4 message and it was successful. That's why it fetched all other messages. So circuit is open again. Everything is fine. There is no error. And that's why I start processing the message again. It's fetching the message from the queue. And product created successfully, we are getting that message. When service was up and running, it fetched one message from the queue and it was successful because service was up, and then the circuit state went to closed and we start fetching the messages again. So this is how we can implement the circuit breaker pattern. This is very important pattern because when we are not able to process message, they will not be acknowledged because of error inside the flow. The message will be returned back to the queue and subscriber will fetch the message again and it will again return back to the queue. Unnecessary fetching those messages and calling the down service, the service that you cannot connect. Instead of that, we can implement circuit breaker pattern and we can stop fetching the message for some time. That way, in the meantime, when service heals up, when it comes up and running, we can start getting the message again and we can check by pulling one message. And if that message is successful, we are able to call that service, then circuit will close again and subscriber will start receiving the message again. So in this video, I explained about Anypoint MQ. I described different feature of Anypoint MQ. I showed you how to use queue, how to use dead letter queue, how to use exchange for publish subscriber design pattern. And at the end, I showed you how to implement circuit breaker pattern in Anypoint MQ. I hope you like this video. If you like this video, please click the like button and subscribe the channel. Thank you for watching. Thanks a lot.